Welcome to trigonometry. In section 7.1 and 7.2, we will be exploring the Pythagorean theorem and the converse. Our goals will be to use the Pythagorean theorem to find lengths of sides of right triangles and use the Pythagorean converse to classify triangles as acute, obtuse, or right. Now you've seen the Pythagorean theorem most likely before. Pythagorean theorem is specifically used for right triangles only. So let's draw a sketch of a right triangle. Make sure we have a right angle in there. We label the hypotenuse as C. The hypotenuse is across from the right angle. Use that right angle like an arrow. There's the hypotenuse. The legs, the sides adjacent to the right angle, the sides touching the right angle, we'll label as A and B. And we write the Pythagorean theorem, C squared equals A squared plus B squared. There's a reason that we always put the hypotenuse, or C, first. We'll get to why that's important later. Let's take a look at the first example that you have. Solve for x in each right triangle. Simplify answers. So noticing in here that the right triangle is pointing to this side. This is the hypotenuse, so this is our C. Let's write C squared equals A squared plus B squared and plug in the numbers that we have. C is x, so x squared equals, now A and B are the legs. Being that we are adding them, it doesn't matter which one comes first. We can say 5 is A, so 5 squared plus 12 squared. We can grab a calculator if we need to, or evaluate 25 plus 144. So x squared is 169. Take the square root, and x is 13. Notice we got a perfect square. 169 is a perfect square. When we took the square root, we got a whole number, not a decimal, a whole number answer. X is exactly 13. When all three sides, like the 5, 12, and 15, are whole numbers, that creates what's called a Pythagorean triple. A Pythagorean triple is a set of three positive integers that satisfy the Pythagorean theorem. Satisfy means makes it work. Meaning when we plug in the numbers to the Pythagorean theorem, we actually do get that it's equal. C squared does equal A squared plus B squared. Some very common triples, the ones that are used most frequently, are 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. There's actually an infinite amount of triples. These are just the ones that we see a lot. And if we want to save time, if we want to make our lives easier, not have to do as much work, we want to memorize these triples. So let's write ourselves a note to memorize these triples. These are going to help make our lives a lot easier. So we see 4 of them, and obviously we can memorize these, but it's also good to know that any multiple of these triples creates another triple. Remember, we studied recently similar triangles? Well, similar triangles can be created by multiplying all of these sides by the same scale factor. For example, if I take the 3, 4, 5 triangle and say times 2 to all 3 sides, that makes a new triple. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. 6, 8, 10 is a triple. If I multiply all these times 3, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. 9, 12, 15 is another triple. So again, it's important to memorize these 4 basic triples, and then to know that we can create a triple from any one of these. So again, memorize, it'll make your life easier. Now, going back to that previous example, if I had known that the triple 5, 12, 13 exists, and I see two sides are 5 and 12, I don't even have to do the Pythagorean theorem. Uh-oh, I just realized I wrote 15 when I got x is 13. Well, knowing the triple would help me to know also that I'm correct. 5, 12, 13 is the triple, therefore 13 should be the answer. I don't even have to do the Pythagorean theorem in a case like that. Let's look at a couple more examples. In number 2, I see 12 and 16. First thing I want to ask myself, is this a triple? Because if it is, then I don't have to do any extra work. These are both positive whole numbers, so if they are positive whole numbers that are part of a triple, then I know the hypotenuse, what the answer will be, without using the Pythagorean theorem. So I see that 12 and 16 both have common factors. If I can think of something times 4, both of these can be divided by 4. 12 divided by 4 makes 3, 16 divided by 4 makes 4, and what do I see? 3, 4. What should the third number be? Well, the 3, 4, 5 triple, one of the most popular, 3, 4, 5. So if 12 is 3 times 4 and 16 is 4 times 4, the hypotenuse needs to be 5 times 4. 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So without having to use the Pythagorean theorem, I know that x has to equal 20. Is this a triple? Yes, and I was able to use my 3, 4, 5 triple. Now looking at the next one, 9 and 12 are two of the numbers. So I might say, oh yeah, there's 9, 12, 15. So my first question, notice to myself, is this a triple? The answer to this, surprisingly, is no. But wait a minute, didn't we just say 9, 12, 15 is a triple? Yes, we did. However, what is the biggest number of all these? 15. The biggest number will always be the hypotenuse. But where is the hypotenuse in this picture? Across from the right angle. Use it like an arrow. Here's the hypotenuse. This should be my C, yet my hypotenuse is supposed to be 15. That's why it's not a triple. So we must use the Pythagorean theorem here. So let's go ahead and do that. C squared equals A squared plus B squared. C was our 12. 12 squared equals A and B are the legs. X squared plus 9 squared. 144 equals x squared plus 81. Subtract 81 from both sides. We'll move to up there. X squared equals 63. Take the square root. If we type in square root of 63, we get a decimal. But remember that our direction said simplify. So I'm going to break this down. X, whoops, no more squared. 63 is 9 times 7. Square root of 9 is 3 with a 7 left over in the radical. 3 square roots of 7 is my answer. Let's take a look at another one. So remember what I was always asking myself first. Is this a triple? Because if it is, then I know it's going to be easier. I see a radical, therefore no, this one's not a triple because it's not an integer. That's a radical. So I must use the Pythagorean theorem. So let's do it. C squared equals A squared plus B squared. Always write it down first. C is across from the right angle. So there it is. Use it like an arrow. Here's my C. 6 squared equals x squared plus, now I have more than one number here, so I'm going to put parentheses around it. 2 radical 2 squared. 6 squared makes 36. When I square 2 square roots of 2, I can square them one at a time, or I can think of it as 2 square roots of 2 times 2 square roots of 2. Now, the 2 times the 2 makes 4. The square root of 2 times the square root of 2 makes 2. So altogether that makes 8. 36 equals x squared plus 8. Subtracting 8 from both sides, I like to turn it around so the x is first. X squared equals 28. Take the square root. 28 is not a perfect square, but can be written as a perfect square times a non-perfect square, 4 times 7. Square root of 4 is 2, and 7 is left over. 2 square roots of 7. Know how to simplify. Number 5. So let's see where the x is here on this part of the triangle. And that means I have to know two sides to get the other side, but I don't know what this side is, and I need to know that side. So we're going to start by using this triangle, because I know two of the sides in this right triangle, 24 and 25. In fact, those are two numbers that are part of the triple. The triple that I remember, 7, 24, 25. So that means the missing side is 7. So now I do know that missing side. I can get rid of the question mark. And now I know this is 7. So now I can use the Pythagorean theorem. C squared equals a squared plus b squared. Here's the right angle. Use it like an arrow. There's the c. X squared equals 7 squared plus square root of 26 squared. X squared equals 7 squared is 49. Square a square root. They cancel each other out. They are inverse processes. 26. X squared equals 75. Take the square root. X equals 75 is not a perfect square, but it is 25 times 3. Therefore, x equals square root of 25 is 5, with 3 left over. 5 square roots of 3. One more. Find the length of the diagonal of the square. The diagonal, what does that mean? Here is the square. The diagonal goes from one vertex to the opposite vertex. This is what we want to find. Let's call that x. Now, what do you notice? If it's a square, it has 4 right angles. Here's a right angle shown here. So let's think of it like we have a right triangle. Drawing the diagonal of a square always gives us a right triangle. I don't think 5 and 5 are part of a triple. In fact, you should know a triple never has two of the same numbers. So I'm going to go to Pythagorean theorem. C squared equals a squared plus b squared. Here's my right angle. Use that as an arrow. There's my c. X squared equals 5 squared plus 5 squared. X squared equals 25 plus 25. X squared equals 50. Take the square root, x equals square root of 50. Again, not a perfect square, so let's take the square root by simplifying. 50 is 25 times 2, so x is 5 square roots of 2.